Hello, everyone. Thank you for joining us today. I am Avinash Desireddy, and I am joined by Anup Kumar in the chat. Anup will be helping me with the necessary Q&A in the chat. We both work for Marantis, helping our customers with wide range of use cases like application modernization, cluster setup and hardening, capacity planning, pipeline optimization, and many more. As mentioned earlier, I'll be presenting the talk, and Anup will be helping me with the Q&A. You can use the sessions chat or the comment box to post any questions that you might have. First, I wanted to start by sharing some insights into Kubernetes and container security trends. So these charts are from a recent report, the recent report by StackRox before it got acquired by Red Hat. So what this report tells us is like approximately like 94% of 94% of them experience at least one security incident in last 12 months. And there are like approximately like 55% of the respondents are expressed impacted with the innovation or with the developer experience because of security concerns. And around like 59% are worried about unaddressed security or compliance needs or threats to their containers. I'm hoping this session like will help you all with some insights into how you can strengthen the security practices within your organization. So let's dive in. Here is the cloud native view of security. Uh, it follows it follows a layered approach, like which is widely used in securing software systems. The first layer is code. We have the code is packaged in containers, and containers are run in clusters, and all these clusters are present in data centers. And it is well known as it is also called as forces of cloud native security. Uh, Throughout the discussion, it is not possible to cover all the security constructs or like the security constructs in all the layers. So we'll be focusing on the authorization, admission policies, and then the network policies from the cluster layer of in the throughout the discussion. First, covering. So here I wanted to go through like a scenario in order to explain these three security constructs. On the left side, we are seeing like three application groups or three tenants. We can call them as represented as like blue, green, and red. Three application teams like has their own security requirements. For example, like application blue should not have any visibility into a green or like the red or any other workloads in the cluster. They should have their own isolated space so that the users within the team uh, can work in a way that they have their own private segment in the cluster. So how can we achieve that is by isolating these teams like with the specific access rights. And once the users are given access to these cluster, they can run any type of workloads. So how can a platform engineer who is managing the cluster can protect the cluster from the type of workloads these the different users are running? And once the applications are running in the cluster, how can we protect them? Like application A can talk to application B. In this case, application green has can try to connect to the application blue. So how do we protect the network layer so that so that we have like better security? So talking about like the first one, in order to give access to these three teams without impacting with each other, this is like primarily required. This is primarily required. Like we have multiple application groups with own security requirements. So RBAC comes into picture. RBAC is RBAC enables you to configure like fine-grained and a specific set of permissions on how users can access different Kubernetes objects. Uh, Going into like more detail. So in Kubernetes, The users are represented as subjects. So subjects is like is categorized as like a user or a group or a service account or an application account are grouped as are referred to as subjects. And on the right side, we are seeing we have like resources and verbs or actions. Resources represent the different Kubernetes objects in the cluster, like namespace, role, secret, or like a volume or network policy. These are all represented as resources in Kubernetes. And the verbs uh, tells us like what verbs are the set of actions that can be performed on the resources. For example, if we take a namespace resource, we can either create a namespace or delete a namespace, like do some modifications, uh, etc. So tying both resources and actions is done by an object called role. So in this particular sample snippet, like what we are seeing here is this: we are creating a role called role blue, and role blue is capable of creating, deleting, and listing deployments and service objects in the cluster. The role by itself is not active. Whenever we create a role, it is not active by itself. It needs to be tied with a specific user. It can be tied with multiple application groups or a single application group or a single service account. So the role can be tied with a subject using a role binding. When we create a role binding object, that's when our role will become active. So in this case, we are creating a role blue with the blue for the blue user, and here is like the representation where like we have the role reference, which is referring to the role blue. The role and role bindings are namespaced. So if we have to apply a role or like you know, create an access control at cluster level, that means with this particular role, a user cannot create a namespace, or they cannot uh, create a create an object which is not namespaced. That's when we create a cluster role or a cluster role binding. With that, let's look at like a short demo where we create namespaces for these three tenants that we have: blue, green, and red, and grant access to application users to respective namespaces. Once we grant access to the respective namespaces for the respective users using roles and role bindings, we'll deploy the sample application and test them out. And here is like the environment that I'm using. So I just like provisioned like the nodes and integral components on AWS, and the Kubernetes engine is it's an enterprise grade Kubernetes engine. I'm like familiar with this, so I'm deploying this. I deployed this on AWS, and we'll be just using lines to access the cluster. And all the code snippets that I'm like running, they are like uploaded in GitHub, and you can find them here, avinash.ready/KDS security workshop. With that, let me quickly walk you through the snippets, like how everything looks together. So here we have step one. So I'm looking at setting up the blue user namespace, where we are defining the namespace object, followed by the role binding for this particular user. This role uh, can perform these specific actions on the resources that are listed in line number 20. And we need to attach this role for a user. So in this case, like my user name is blue. So I'm attaching this user to this particular role binding. So let's apply this role on, let's apply this manifest file on the cluster. So here is like a quick cluster view. So this is the cluster like that I have provisioned, and the cluster has like one master node and three worker nodes. What I'm going to do is, if we just look at all the existing namespaces in the cluster, we don't have a blue namespace in the cluster. We'll go ahead and run the kubectl command, set up blue namespace, set up blue. So using an administrative account, I'm performing these operations because the admin user has capabilities to create these role bindings, etc. So I've just configured the kubeconfig file for the admin user in here. And using the admin user account, I am setting up the blue user account, uh, creating the blue namespace and then granting respective permissions for the blue user. What this done is like it created this blue namespace. If you look at the age, it just created like 2 seconds ago. And if we just go into the access control section, we can look through our roles, like the blue role is created and with all the set of permissions that we have provisioned in the file, and then it created the role binding. Now we can connect to the blue user. So I'm just switching into the blue user. So the kube config file is configured in here using the add cluster mechanism. It just asks us for the kube config file that is associated for the user. So uh, I've configured it here already, and now we are logged into the blue user. I'm just going to select the blue namespace, or maybe just blue namespace because the user only has access to blue namespace. And also the user has access to just to create deployments or pods or secrets. So that's the only reason, that's the reason you see only 3 different type of workloads in here. But when I look at the admin section, we see like there are admin has capabilities to do a lot more operations compared to a regular user. So from here, I will switch to the RBAC directory. And then here I have the manifest file. So manifest file for the blue application is this one. So if we go through this, so like currently like deploying 3 instances of a container and creating a sample service of type cluster IP. So let's go ahead and deploy blue app, and then it has to go in the blue namespace. This is optional, like since I've already selected the blue namespace. So it created our pods. If I go into deployment section, we see our deployment blue created, and it has like the 3 pods running. So it is successful. Now, the same way, I'm going to upload or create grant access to the green, uh, create the green namespace, and then onboard the green application team or like the application users onto the cluster. So running this particular like setup green.yaml file onboarded the green user, and then created the green namespace over here. And once I'm in here, I'll be switching to the green user account. And from the green user account, we'll try to perform some operations. I'm here, the namespace is green, and just looking at the deployments, I'm going to -f deploy green app. But before just deploying it under the namespace which it has access to, let's try to deploy it in blue namespace and see what happens. So when we try to deploy it to blue namespace, this should fail because the green user does not have access to create deployments anywhere other than this particular namespace. So like the user is forbidden, or like it says like clearly access denied. If we just try to run it under green, it should be successful because the user has access only to this green namespace. Similarly, the access can be set up for the red user. Based on like the time constraint, I'm going to back to the presentation. Okay, now we have deployed like like three applications. One other thing is let's try to access these applications. So I am under Blue user account and I'm just using the cluster IP. So I'm just going to do a port forwarding and try to access the application to make sure what I intended was correct. So the manifest file has this title and description, and then my application is running successful. So all good. So what we did is like now the users are happy because they can run workloads on their cluster securely with and more confidently because no other application teams have uh, access to their resources. And from there, we'll move on to like the scenario two. Now, in scenario one, we have seen like the users got access to the cluster and they happily deploy the cluster. Now, what happened is like all of a sudden, like some of the worker nodes in the cluster are not responding as expected. And further investigation, like by the operations team or like a platform engineer, revealed that some of the pods that belong to application blue started consuming like a lot more memory than expected. So this is like most common scenario that I can come across in the field when working with a customer where the pods are not set up with the resource limits. Recently, I've been at a customer site and they are running a huge workload, which is this workload is Java based, and the Java heap size on these applications started growing drastically, and it impacted like several nodes in the cluster. As a result, like there are like several long nights in terms of resolving that and then resolving it, resolving it. We know the solution, which is like we need to apply like resource limits on these containers. And once these resource limits are maxed out, we have to consider implementing auto scaling solutions and possibly increase the number of replicas. But in order to implement these resource limits, now the platform engineer like onboarded this application user with the list of application users, like, and eventually like over time, like there can be like 50 or 100 different tenants that are using the cluster. The platform engineer has to track down who is the owner of the application, and once they have the owner information, like they have to reach out to that particular application team and ask them to make the necessary changes, and also they can understand they can learn about their resource requirements and apply those resource quota and limits on these namespaces. The once the change making coordinating all these changes is time taking process, and the changes has to be like tested like from lower environments to higher environments. And once the changes are in production and everything seems to be happy, but after a while, like the same problem reappears with the application green. Now the platform engineer starts thinking, okay, how do I make sure all the applications like that are being deployed in the cluster has these resource limits or they follow XYZ policies in the cluster? Do I have to reach out to like these 50 or 100 application teams and coordinate changes, educating them? Or one of the well-known practices, the infrastructure team or like the platform team, like they define best practices by writing docs or wiki pages and then sharing, performing some roadshows with the application teams. Uh, so all the new applications follow these best practices. Okay, now the best practices are defined, but how do we ensure the best practices are being followed by these different users? Should we perform monthly audits, or should we perform like a quarterly audits and identify the bad actors in the cluster and notify the respective teams to fix it? So these are like the set of challenges that a platform engineer like goes through when the cluster, when there are like several tenants, when the cluster is shared among several tenants. So With that, like let's do a quick poll. Like we can scan the QR code and let us know like how many of you find challenges like while agreeing to the cluster best practices with the application teams. That like let's take like few seconds over here, like a minute over here. You can just scan the QR code from your mobile device and start or go to the link slido.com and enter the code and respond yes or no in the chat, yes or no accordingly. Okay, okay, we see the polls are coming. Okay, few more seconds. Okay, let's move on. Like we have approximately like six polls where everybody ran into challenges while agreeing to these best practices. So how do we overcome this? How do we address these kind of challenges? So it can be done by enforcing certain policies on the cluster. How do we enforce what do I mean by enforcing policies in the cluster? uh, like tying back this to like a real a real time scenario. When we let's say we get like a flight ticket to let's say to like and then to fly to a certain destination like Miami. We can since we have our flight ticket, we can go to the airport and then check in and then take our flight and then fly there. But nobody, but you cannot enter into the airport or you cannot cross the security checkpoint if you are not following certain rules, or if you are like let's say carrying a weapon or carrying liquids beyond certain limit. There is like a security guard or someone at the airport continuously monitoring the users who are coming in and monitoring each person that's coming in and then allowing based on certain policies. So for our Kubernetes cluster to make it more secure from the type of workloads that are being run, we need a, some kind of like a security checkpoint uh, checkpoint to validate all the incoming workloads into the cluster and then allow them to run on the cluster as needed. So some of the common policies that we can set up, or like not just some of them, like these are like the critical policies that needs to be set up on the Kubernetes clusters, like based on like the different uh, based on my experience working with like different scenarios and then at different customer places. These are some of the key ones that needs to be eh, where the policies need to be created, and we can create like many more based on the organizational security requirements. What all the best practices that we have in our best practices documentation can be converted into policy, so it is easy to represent or easy to enforce them on the developers or the application teams. So now, how can we set up these policies? These policies can be, there are several tools like Open Policy Agent, or also referred to as OPA or Caverno, that are designed to address these problems. And OPA is one of the popular framework that is used just to address these need, not just with the Kubernetes, but several of the cloud native but for the applications are like several tools out there like Kafka, Terraform. We can integrate OPA seamlessly with different projects. Just because of my familiarity with OPA, I have chosen to present OPA here. uh, but Caverno has a similar set of capabilities, and where we can enforce policies on Kubernetes cluster. OPA is like a CNCF graduated project, and it is a general purpose policy engine. That means it gives the ability to decouple like decision making logic from the policy enforcement. That means like we can design our whole entire microservice, and at some point like we wanted to enforce certain policy, then we can take the OPA library and then embed with our intercept inject in our application. So it can intercept our user requests and then allow them or and then make a decision to allow or deny them. Uh, uh, it empowers like admins with more control over the systems. And it uses a separate like language called like Rego, which is more declarative and easy to read and write. Since this OPA is more generic sort of uh, the implementation, the Kubernetes implementation of OPA is referred to as like gatekeeper, gatekeeper, and it is implemented as an admission controller in Kubernetes. So how does it all work? Like we are talking about like the policies, we are talking about like intercepting like the user requests, and then allowing the work, and then denying or allowing certain workloads. So like the way so initially what happens is the platform engineer defines or like sets up the gatekeeper on the cluster. That means like he installs the necessary components to install gatekeeper, and then he converts the best practices documents or like the generic policies into policy constraint templates or like the policy constraints, which are represented as YAML files similar to all other Kubernetes objects. So once we have these policy constraints, they are applied on the cluster, and they are stored as CRDs in the cluster. Once once we have all the policies in place, whenever a user tries to deploy their application, in this case like app.yaml, where it is just like doing a deployment, when a user tries to apply it, API server intercepts that request, and once it intercepts the request, it passes on like the request is received by the API server, and then the request is taken through like several admission controllers in our Kubernetes in a Kubernetes cluster. One of the admission controller is gatekeeper. So the input is then passed to the gatekeeper, and gatekeeper validates the request against the policies that we have. So once we have all the once it validates the policies against policies for the request, it makes a decision on if all the policies are met, then it approves. Then it responds back to the admission controller is like we can allow this request. We can allow this request. So then further the request is persisted or the persisted in the etc database server, and then kubelet does its magic to run our application on the worker nodes. But let's say when the request is denied, like if certain policies are not met, then a deny request is sent back to the user with a custom message. So whenever we are defining a policy, we can define like we can define certain custom messages so that the message can be sent back to the user. For example, like you are not the application does not follow node should have a certain label. If you are not familiar with how what labels should be included, you can just reach out to the operations team or engineering team, and then we can provide the respective URLs or contact info in there. So with that, like let's see how exactly like OPA works in action. So I'm going back to to my cluster where we define where we deployed this sample application. Uh, for simplicity, it's actually like easy to install OPA, but for the sake of the demo, I have already installed OPA in the cluster. if when I say like OPA, it's the gatekeeper, which is the OPA implementation in Kubernetes. So we can you can see all the pods related to the gatekeeper are running in here. So what we'll be doing is we'll be creating the policies on the cluster. So the policies that we are going to look at is they're again like they're part of the GitHub repository, and the policy that we are going to look at is the node port policy. So what this node port policy does is we create this constraint template. And what this does is if any application is using a node port, then it is not uh, it is restricting users to make use of node port. This is required because like when we have like several application teams and everybody wants to use certain node ports on the cluster, will eventually like run out of the ports that are available in the uh, cluster. And the best practice says we should be using ingress in place of node port until and unless like there is a specific use case requirement for a node port. So this policy, what we are defining is node port is not allowed, and it is just recommended to expose the application using ingress. And let's say if your application have like how this ingress needs to be used, or uh, for some XYZ reason, like we must have an output, then in that case, like reach out to ops team at this certain like email address. We can like define like a nice message. And then uh, where this template like for what type of objects. So this is a representation in of the of the manifest file or the constraints in gatekeeper implementation. Here we are saying this is applicable to all the service requests, like any user creating a particular service, then invoke this particular template and do the necessary for validation that is defined here using the Rego language. So from there, what we are going to do is I'm going to create a node port service of type node port and see what happens to the cluster, what happens to our request. So switching back to my user, I'm going to run as a blue user, but at first I'm not going to create the service using uh, I'm going to create the surveys using node port, like without policies. So if I just do node port so creation of node port service, when I apply this when I apply this, it created the node port service. So if I just refresh my screen, we see the node port service got created, and it assigned a random port. And this can repeat like multiple times. So like when different application teams try to use it, they'll be assigned with like different node ports, and then eventually we might run out of it. So now the platform engineer decides, okay, we should restrict the use of node port. So we are going to create these policies. I'm going to execute the two manifest files on the cluster to create the policies. So this is now the two policies are created. We can just see they got created under the constraint template. So these are all the CRDs that are associated with Gatekeeper. And here is the two objects that we created. From here, we'll go to the blue user, and from blue user, we'll try to recreate this service, but I have to remove the existing one. And once I remove the existing one and do a quick refresh, it's not there anymore. And when I create it, should reject the request. So it rejected the request and it just gave the nice error message or what actions that we need to take. But when I try to create a different service with a cluster IP, it the request is allowed, and then we can see the request, the service object got created. But when we created like the node port object, it is rejected. Okay, so going back to the presentation, so we successfully demonstrated like the node port, and there's another example in the GitHub repository, which you can try it out by applying the policies and then uh, running the demo application. Okay, now the app now let's say like the application team like blue and green, what we did is like blue and green successfully ran their applications and they are allowed to run on the cluster, but whereas application red did not follow certain policies and they are not allowed to run those respective objects or objects in the cluster. That's how the policy agent OPA can help protecting the cluster. Now we have the users their own isolated space, and then the cluster is protected. With that, let's move on to the scenario 3, where our application blue, well, new features got added to the application blue, and now the pods must connect to an external database to get some data, or and then not only to the external database, but it also has to connect to the pods that belong to the application B. So what happens in the cluster is by default, like any pods in the Kubernetes are not isolate or non-isolated. What it means is any pod can connect to any other pod in the cluster seamlessly without any restrictions. So they can accept like traffic from any source to any destinations. If we like tie this back to our traditional like scenarios where we have like Linux host, and we don't want anyone to SSH into this Linux host or do attempt to it. There are like firewall rules in place for different between different network subnets or like different between different IPs, which IP is allowed to connect to which particular IP or certain port is defined using these firewall rules. So we need to secure the Kubernetes environment and the applications that are running within the cluster using a similar mechanism. And that can be done using network policies in Kubernetes. So what network policies can do is like they can control like the traffic to and fro from pods, similar to how firewall rules allow traffic from a specific IP or the host. Firewall rules are like namespace, and since in a Kubernetes environment, like as we scale up our pods and scale down our scale up and scale down our deployments, the different pods gets created and then destroyed. So we need uh, so we cannot assign or we cannot it's very hard to predict the IP addresses for these pods and hard to provide certain ranges. So uh, so that's where these policies can be defined based on a pod or a namespace selector or an IP range. Here is like a sample snippet like from the Kubernetes documentation on how a network policy looks like. So this policy, so the kind is of type network policy, and it gets applied to the default namespace. And to which of to which pods this policy should be applied is defined by the pod selector. Like so, this policy is applied to all the pods which has like labels which has the label matching label of role DB, and we need to control both egress and ingress traffic. If we don't specify egress, that means only ingress traffic is controlled for this particular pod, not the egress. And how ingress or egress should be controlled is defined in the respective sections. Like where if it is an IP block, we can provide the CIDR. if it is like namespace and pod, we can use the match label selection. So this is a quick representation of it. As I mentioned earlier, like the traffic uh, before that, the quick poll just to see like who are all using network policies in their production or in their organizations right now. Let's take a quick minute to uh, get the poll in. You can scan the QR code or use the Slido. Okay, we have several people like who are like just thinking about using it or like not using it, not using it. So let's dive in on how they can be used or how they need to be applied. Because we need to protect, we are protecting the cluster from the we are protecting the cluster and also protecting the tenants area on how they can communicate with what API resources, what objects like that belongs to a different user accounts. But between application to application, there is no restriction. Like any application can try to connect to any other application using the IP and port if they know what service is being exposed in that. So that's where we need to use network policies. By default, since by default, like pods in the cluster are like non-isolated, we should start by creating a default denial. That means every pod should like none of the pods should have access to connect to any other pods in the cluster. This is the one of the well-known like template where on the pod selector, like the empty defines like it is applicable to all the pods in the defined namespace, and the egress and it is of egress and ingress and egress. Like nothing is specified except one policy for a pod to resolve the DNS name of a service. Create or we create this egress policy so the DNS resolution can be done. If we don't provide this egress rule, even like the DNS resolution will fail. If you have to connect to an external IP, then we cannot use the DNS that is built in. So connecting to back to going back to our scenario, let's see what steps needs to be taken if you have to connect our application blue to MySQL instance. So step one is like we'll be opening the firewall rules on like the DB to allow connections from the cluster subnet. So here in this case, the cluster is on subnet 172.31.0.0/24, and all the and the database is running on like port 33,006. So we need to first open the firewall rules on the database layer, and then second we need to open the firewall rules on the nodes to allow traffic to the MySQL instance on the port that it is running on. So this one will expose the connections between the worker nodes to the MySQL. Now in the previous step, we created a default denial policy. So none of the pods can communicate with any other IPs or any other IPs in the cluster or outside of the cluster. So that's where we have to create an egress network policy, where our egress network policy syntax looks something like this. We have this match a label, and then policy type is egress, and then it's connecting to this particular IP range on a TCP port. And the similar way, so that is like when our application tries to connect to an external service. If our service, if it has to connect to an internal service, then we need to do two things. Like step one is from the source, we need to create an egress policy to the destination, and at the for the destination pods, we need to create an ingress policy so the destination can accept the respective connections from the source. With that, let's look at like a quick demo on these network policies on how they can be applied. So for this, I'm just going back to my snippets, and under network policy section, we have this MySQL and we have one test application. So I'm going to run the test application first. I'm in the network policy directory. I'm going to deploy the blue application. So now this is the second version of the application, so which got deployed successfully. And when we try to access this blue application using its cluster IP, we can see the application is running, and I've exposed it on MySQL endpoint, and we see the connection status is true. Let's see what happens as soon as we deny, as soon as we create the deny policy. Default deny all and -n blue. So I've created a deny all policy, and when I go back to the application and try to refresh my page, now it is trying to connect to the MySQL DB, but the connection fails. And we can see the nice error message saying that like the connection status is false. The reason for it is it timed out. The policy got applied. Now repeating the same thing, and then we're going to create this network policy for just to open the access for this particular MySQL. And our policy worked. Like initially we denied all the traffic, and then we allowed just this particular uh, allowed just the parts that needs to connect to MySQL with necessary access. Okay, going back to the slide. Okay, going back to the slides. The second use case, there's like a snippet in there because of the time constraint. I'm moving on. So the network policies is something like native to Kubernetes, and there are only like a few CNIs out of all of them like support network policies. And network policy concept can also be applied. You know, like each CNI provider has their own way of providing network policies, like enforcing network policies on the cluster. And some of the popular CNIs that support network policies are these. So uh, so with all the three security constructs that are shared. So here are like the key takeaways from what we have experienced, like what I've experienced from different customers. As soon as like the cluster is provisioned, either in AWS or GCP, or like using Miranda's Kubernetes engine on-prem, they think about like onboarding the giving access to the users straight away, and then once the users have access, the user will start deploying these applications. But before, as soon as the cluster is provisioned, we need to start thinking about building a strong RBAC strategy. How the user should be given access, what access they need, are we granting more than what is needed? And so that's one strong thing that we need to be considering. And at several and one other common scenario over here is there are like several roles that are created but they are not in use. they're not actively used. There are several like role bindings for the users who don't need access to the cluster. It's one of the common pattern like that is seen in different organizations. So it is very crucial to perform a regular cleanup of these unused RBAC policies or like uh, unused RBAC roles or role bindings. So only the necessary users has access to these clusters. And then enforcing policies. So if you don't enforce policies, like we have seen, like what happens, like a user uh, can create either a privileged pod, or they can create run images from untrusted registries, or they can run uh, without a label to certain namespaces which are easy to identify what that application, the purpose of the application or the cost center it belongs to, etc. So it is very crucial to enforce policies on the cluster. So there is a better control on what users are doing in the cluster. And then the start with the zero trust network policy. As we have seen, like the communication within the pods is not isolated. It is like not running firewall in the organization. We need to, even within the cluster, since it is shared between different application teams, we have to start thinking, implementing the network policies. So with the denial. Uh, with that, uh, thank you so much for joining me today. And for any further questions or like follow-up discussions, I'm happy to share like my experience working with different customers, and what the best practices that uh, that can be implemented to secure your environment. And here is my like Twitter handle and mine, and then Anoop's Twitter handle. You can reach out to any of us, and